question asks us to use oxidation numbers to determine whether this reaction is an oxidation reaction, a reduction reaction, or neither. To do that, we will look at the atoms that change during the course of the reaction. For this particular reaction, it would be this carbon atom and this oxygen atom. The rest of the atoms stay the same, so calculating their oxidation number doesn't so much help us out in this particular example. Our equation for oxidation number is the number of valence electrons the atom wants in its neutral ground state, minus the number of electrons it owns in this particular structure. We'll start with carbon and we'll work with oxygen to see how the oxidation number changes throughout the course of this reaction. Carbon wants 4 electrons in its neutral ground state configuration. In this particular structure, the number of electrons it owns depends on the electronegativity with the atom that it's bonded to. Carbon is bonded to oxygen. Oxygen is more electronegative than carbon, so the 4 electrons in the double bond are all owned by oxygen. Carbon does not own any of those electrons. The carbon-carbon bond, both carbons have the same electronegativity, so the 2 electrons in the carbon-carbon bond are split equally between the 2 carbons. So the carbon in question owns 1 of the electrons in this carbon-carbon bond and 1 of the electrons in this carbon-carbon bond. That makes a total of 2 owned electrons for this carbon. 4 minus 2 then, the oxidation number for this carbon in the starting material is the +2 oxidation state. Oxygen wants 6 electrons in its neutral ground state configuration. It's more electronegative than carbon, so it owns all 4 of the electrons in the pi bond, and it has 2 lone pairs for another 4 electrons, for a total of 8 electrons that oxygen owns in this starting material. 6 minus 8, the oxygen is in the -2 oxidation state in the reagents. Let's see how that changes in the products. Our carbon is bonded to oxygen. There are 2 electrons in the carbon-oxygen bond. Oxygen is more electronegative. Oxygen owns all of them. Oxygen is also bonded to carbon. The electronegativity is the same, so it owns 1 of the electrons in this bond and 1 of the electrons in this bond. Oxygen is more electronegative than hydrogen, so it owns both electrons in the carbon-hydrogen bond. That brings carbon's a total electron count to 4. So it wants 4 electrons in its neutral ground state configuration, and in the product, it owns 4 electrons, 1 from each of the carbon-carbon bonds and 2 from the carbon-hydrogen bond. That makes the oxidation number of carbon in the product the oxidation state of 0. Oxygen still wants 6 electrons in its neutral ground state configuration. In our product, it owns both of the electrons in the carbon-oxygen bond, it owns both of the electrons in the oxygen-hydrogen bond, and it has 2 lone pairs for another 4 electrons. So it owns a total of 8 electrons. 6 minus 8, the oxidation state of oxygen in the product is -2. Comparing the starting material to the product, the oxygen does not change oxidation state in this reaction. The carbon gains 2 electrons to go from a +2 oxidation state to a 0 oxidation state. That makes this particular reaction a reduction reaction.